Hello everybody, welcome back to the third video, and today in this video we're going to learn about how to solve inverse function. I believe as you know in the previous videos we have done the introduction to function and how it works, and it is normally from a set of objects or what we call domain to a set of images or what we call the codomain, and of course the better way to really express that is known as range. So the idea is quite simple. When you have a function, it allows you to go from point A to point B. And function serves as what we call a processor. So if you look at it very carefully, if the processor could get you from a domain to range, a domain to codomain, it is also viable and feasible for you to go from a range back to the domain. So that is like a reverse process, and this is what we're going to do today. So now if you look at a very normal function, let's just say this is a set of domains, okay, it's a set of domain, and this is a set of range, right? Okay, and we know that from here to here, it involves a function, okay? Function x, let's just say. This is how it looks like. And what inverse function is that it goes from range back to domain. For inverse function, you got to be very careful because now we know that this range is no longer a range for inverse function because this range is equivalent to the inverse function's domain. And of course, this becomes its range. So this is what you need to know. Alright, so this is a very normal structure of how inverse function works. How do we know that in a way that a normal function can be inverse? So the idea is very simple, because if you understand how the normal function works, we know that what makes a function is the relationship. If the relationship is one-to-one relationship, we know that it is a function. Or the other way around, many-to-one function is also considered as a function. Okay, if you look at the whole thing in a different perspective, from one to many and many to many, these two are not considered as a function. So if you look at it, for inverse, you do know that this is how it works. So from one to one, even if you inverse this, even if you swap it around, okay, it will still be considered as one-to-one function. Okay, so one-to-one function is there's always inverse to it. And what about many-to-one? Because many-to-one, as what I just mentioned, we do know that many-to-one is also considered a function, isn't it? But how if we inverse this? When we inverse this, this is now considered as one-to-many. Therefore, many-to-one can never have an inverse function. So to conclude this, it's very simple. Only one-to-one function has an inverse. So that is what you need to know. So understanding this whole thing, because right now I'm going to show you an example on how you can inverse the function. So let me quickly just erase this, okay, just to let you see how it works. Okay, imagine you're given a question, function f, okay, equals to 2x plus 5, okay? And all the x's in the equation are real number. So real number is any number that is, in a way, has negative or positive value. It could also be large or small value, or even numbers that has decimal or whole number. So all these are considered as real numbers, real value. And in a way, as opposed to this is what we call imaginary value. That would, it is in a way it's something that you will learn, maybe in A level or somewhere, further down the road. So don't worry. So the idea is this is a normal function, and we will see how we could inverse it. So this is how I will normally suggest you to do it. Okay, I'll first assume that the inverse function equals to y. Okay, later I'll explain to you how this works. And as you know the relationship, let me just sketch it out on the side so that you can see it very clearly. Okay, we know that in this case, let's just say it starts with this. Okay, so we got to understand that the perspective is slightly different. So could you imagine if you put fy, you obtain x, correct? So if it's an inverse function, it will be f inverse x equals to y. So do you see this relationship? Okay, if you could see this relationship, then you will understand why I could make such, an assumption. So inverse function x equals to y, therefore fy equals to x, because technically they are, in a way, reversed and in a cycle. So this is an assumption that I make. So sorry. How do we solve it? So in a way, this is how you solve it. Okay, we assume that fy equals to x, right? So we substitute y into the equation. So what do we get? We get a 2y plus 5, correct? You see, all I did was I changed the x to y, and this equation will reflect the change. So 2y plus 5 equals to x. You see, this is a carry on from the previous assumption. Okay, and of course I understand that 2y equals to x minus 5. Okay, y equals to, x minus 5 over 2. And if you notice, the whole equation is made in a way to basically have y as the subject. You see, we already made an assumption that y equals to inverse function f. So now that we know y is the inverse function of f, we could easily substitute it in, and this is now what we call the inverse function of f from this very equation. So this is how you could do the inverse function. Okay, now the last thing that I really want to address in this video is how you could sketch an inverse function, and let me show you a quick one. Okay, so if you really want to know, this is how we sketch the normal function. Okay, we do know that the equation is 2x plus 5, and to plot this, we will find some of these points and we connect them and see how it looks like. So from here, I know that this is on the y-axis. So assuming that if it's on the y-axis, x must be 0. Okay, so technically this is how it works. I need to know that because it's on the y-axis, so the x must be 0. So f0 equals to 20 plus 5, so it's 5. So I know that there's one point here. Okay, and how do we sketch the other point? Okay, now it's on the x-axis. If it's on the x-axis, we need to know that the y equals to 0. So technically this range is 0, so 2x plus 5. So I know that x equals to, 2x equals to minus 5, x equals to minus 5 over 2. So it's negative 2.5. Let's just assume it's somewhere here, okay? Negative 2.5. So this is the line of function, of function f, okay? So how do we actually sketch an inverse? Okay, remember, the trick is this. You have to draw a dotted line based on this equation, y equals to x. Always remember the rule, y equals to x. This is the line that we need to sketch whenever we try to sketch an inverse function. So this is the line, and it acts as a mirror for us to reflect the normal function onto the other side. So how do you reflect it? So this is how you could reflect it. So just treat it as a mirror. Okay, the sketching might not be perfect, but it looks like just a mirror reflecting the normal function to the other side. So this is the inverse function. So far I hope you understand everything that I've just mentioned, and in the next video, what we will do is we will be solving some really hot questions and famous questions that you will find in inverse function, and I hope to see you in the next video. Stay tuned.